we do have a bunch of renowned dignitaries here. So first of all, we would like to invite the very renowned dignitaries who are actually bound to address the keynote facilitation. So we do, first of all, we do graciously recognize the presence of Dr. Jehangir, the chairman of NES Group and MD, SFO Technology Limited. So on behalf of Jehangir sir, we would like to invite Shafi sir to the stage. Shafi sir, please do come to the stage. We're so lucky and proud to have both Dr. Jehangir as well as Shafi sir at this premises. And in order to address the NES keynote facilitation, we would like to invite Mr. Ramesh Kannan sir. He's actually the Managing Director and CEO of Kenyas Technology. Sir, please do come to the stage. Then, for the panel discussion, we do have an amazing bunch of speakers. First of all, I would like to invite Vice Admiral Srikumar Nair, sir. Sir, please do come to the stage. Okay, so it is understood that he is not here at the moment, but he will do come here later. So next, we would like to invite Mr. Rajamanikam, sir. Sir, please do come to the stage. He's the founder and CEO of WP Semiconductor, India's first fabless chip company. With 30 years of experience in the semiconductor industry, he has previously served as a CEO of Tata Electronics. So, most welcome to this amazing session. Next, we would like to invite Commodore Matthew Letra M. Sir to the stage. So he's a CEO of Crancy Defense Technology. He's an Indian Navy veteran, having served the nation for many years, and he was awarded Naosena Medal by the President of India. So most welcome to this amazing session. Next, I would like to invite the session moderator, M.R. Mudalidharan sir. Sir, please do come to the stage. He is a Chief Technical Officer in Tata Advanced System, 45 years of experience in D&D Aerospace and Defense System with 30 years in System Engineering and 8 years in Era Network, US and retired in Tata Group. Most welcome to the session, sir. So, in order to address the keynote facilitation, on behalf of Jehangir sir, I would like to invite Shafi sir, the Vice President of NES Group. So please to come and facilitate the keynote address.
Indeed, it is a great pleasure and stand off in front of my friends, entrepreneurs, and my brothers and sisters, and my professors, and well wishers. Thank you very much, first of all, Government of Kerala give you opportunity to come here and make how my growth 30 years journey. That is a really very interesting stories. Unfortunately, I cannot brief these things to you because my throat problem. And my senior Vice President, Mr. Shafi, and Mr. Thomas, should we show the presentations and brief you. My dear friends, only one thing I want to tell you. In this world, this Indian territory, the Cochin, Kerala is only the right place to start up a company. For example, when I start our organization in 1998, Delhi, lot of secretaries and other people, why you want to go to Kerala? Why don't you do in Karnataka or Bombay or elsewhere? And the secretary showed me, you're going there, taking a water in the hand, dropping down, dropping down. See, this is the way it will be happen. I said, I grown up in that country, state. I built up myself. I am now my state of my India. That is the reason first company we are started in the tool manufacturing facility in Cochin, collaboration with AMP. That is a startup for multinational company in Cochin in 1998. From there, our journey starting. Now we are reached 33 factories we have, and we are blueprint in worldwide, and 8,500 engineers working, not other people also. Everything together is like 9,000 employees working company. And most important thing, we don't have any strike. Any day we don't lose. A day lose you don't have. They are very, very positive and they were very proactive. Gone people coming back, again you want to go to next family. This is what is I'm hearing, that is penetrating in the market. That's the reason a lot of companies coming in. I'm very proudly say that this is what it is. My beloved chairman, Mr. Jawad Hassan, he is the person for navigating, and Kerala is the best destination to do that. However, we should have a focus on tourism, Ayurvedam, and education. The three elements you want to focus. That is also very possible area, and electronics, what just he said. Look at it today, how many engineering college? Look at it, how many medical colleges? Look at it, how many Ayurveda colleges? How many diploma? Everywhere is filled now. And they are getting job, even not here, they want to go elsewhere. The ecosystem we want to build up in Kerala and stay there in Kerala, and we should have a power of in the country and show other countries what we have, how powerful we are. We are working with the niche areas, just fiber optics, and at that time, fiber optics should not be there. Nobody knows what is fiber optics. 1994, our company, that nobody knows what is PC board, what is assembly line, through all, nobody knows that. That area, we are starting this company with tighten our belt and bring up good engineers, and we are move up. All our customers are Fortune 500 rated companies. Nobody loses. The technology, the people are very, very competent. They were very observative, obedient, listening, and do the changes and implement it. What is the important thing? The quality. The quality comes only because of this type of attitude. My dear friends, today we are running after chip packing other companies. We already started the company in our economic zone, and we are shipping materials. We have 3 companies, we are already signed the agreements. One by one as we are starting. Similarly, we are the biggest telephone company which is available, which is sitting with you. The company's equipments and the subsystems, test equipments, everything we are making. We are a big company. We are new factory coming up with test equipments and test equipment and test equipment and what? Automations and artificial intelligence and etc. We have around about 100 people, engineers already taken, we are going to take 800 people. Only for that area, from the association with the Engineering College, Rajagiri, Muthoot, KME, Koyalamangalam Engineering College to take, and we are trained them curriculum in that their studying time. So we are a lot of innovations and other things we are implementing in Kerala, but we are quietly doing that. That's the reason our turnover should be this much. We started with 3 digit, now we are 4 digit. That's what we are. We will go innovative. What is our logo? Innovative, creative solutions. We are not a EMS company. Innovations, where the innovation comes with the good engineers. Innovative, creative, creation also the human being nature. Create solutions coming out from everything. That is our slogan. This is what it is. My friends make a presentation, you know that what are the way we come up, where we are going, where we, and we are by acquiring a lot of new generation companies with smaller, large, we are buying out and add on value for our company. My dear friends, this fiber optic itself is a niche. Only one company making fiber optic components, only Nest. That is our selling point, major points which are coming to my mind. And we are growing every year 22%. So I don't want to tell more about, and not only that, we have verticals too. So when I start the company, why you want to make a mechanical company? Why you want to electronics, plastic injection molding? All the questions my senior people ask me a question. I said, this is my vision. That's we are vertically horizontally integrated facilities. We are the biggest machining facility in Kerala. Now we have 150 machines, CNC machines working in Cochin, and we are the number one. We are working for a big client, and we are signed off a lot of agreement with them, and we are getting more people. This is what it is, and no strike, good people. That's the reason people are coming. What is other people coming here? Taking Vasco da Gama, come to India and get spices and everything, and you go back. Similarly, all other companies are coming. They are taking our resources and taking away. This is what is happening. That's the reason the people are eroding from here. What the government should be do, make a good ecosystem, do that. The ecosystem should be make component manufacturing, not only in the electronics, not only in the software. Every software and electronics is inevitable. Otherwise, software never work. But that time, software, everybody is got after no software. 98, Y2K started time, everybody is got after that. We are stay back and we are concentrating on the hardware. That's the reason we are number one in India. We got several awards from India government. We are the biggest exporter for that in Indian-based companies. This is what it is. You will think it is in the Kerala, the tip of the country. Thank you very much, my dear friends, listening to my speech. And my colleague make a presentation, and you will understand more about what we are. Thank you very much. God bless you. Jai Bharat, Jai Hind.
Thank you so much, Hanke sir. Next, I would like to invite Shafi sir, the Vice President at Nest Group, to have a presentation.
Distinguished panelists, delegates, ladies and gentlemen. Our chairman already explained what we are doing in Kerala in terms of innovation and other things. I will be briefly touching upon the core topic of the session today, that is innovating the future, and what's happening in electronic systems and design as well as manufacturing sphere. I'll make it quick. The total time for this session is, keynote speak is 20 minutes, so we'll try to contain within that. Okay. So electronics, the hardware design as well as manufacturing industry is right now at as you call as the tipping point in India. The future looks really optimistic, and it is something similar to what India was in the IT sector during 2000 Y2K period. Thereafter, we saw an exponential growth in that industry, surpassing the target set by most of the people in the industry who predicted the growth. That kind of growth awaits this sector. But while doing that, this is basically driven by a few factors. One is the domestic consumption growth. As you know, India's middle class is growing, and our consumption is growing, and that is creating demand for more electronics to be made. And some of the policies of the government makes it make in India as a mandatory, so that local consumption is substantially going up. The new markets, which is basically the IoT, the EVs, and this kind of new technology introduction into the market is driving the need for more electronics into the country. And that's another thing which drives the electronic manufacturing sector. Make in India push by the government, both for the defense procurement as well as for the other procurement, is another push which makes this electronics system design and manufacturing a really growth sector. Geopolitical factors is another factor. We have read a lot about China and the policy guidelines required, as well as the taxation threats. That makes most of the foreign US, Europe, and other countries who are dependent on China are looking for alternate pastures, and India comes up automatically as one of the most attractive things. These are the things which is actually driving the future of the electronic design as well as manufacturing in India beyond our expectations. And all the companies in India are in this field are aware of this, and they are all getting ready to harness the full potential of this particular growth strategy. So this, in terms of emerging trends in electronics, because we cannot continue to sustain our current legacy way of manufacturing and designing of electronics, because things are changing. There are few drivers which are causing this need for the changes. One is the things are going into be more and more smarter, smaller, lighter. So all the electronics design as well as manufacturing technology, packaging technology, all are actually undergoing substantial change globally. And our manufacturing systems, designs, and everything has to be fully prepared for that. Otherwise, we will not be able to harness this future growth. Another one is the technology driving, the smart manufacturing, Industry 4.0, those kind of technologies. Unless you adopt, you cannot have an efficient, optimized production process in future. So that's another thing which is driving the innovation into this industry. The third point is the environmental, the ESG awareness globally, and some of the US, European companies will not even look at India as a manufacturing location unless you are committed to this environmental protection, carbon reduction, and all that. So this also means that your product design as well as the manufacturing practices has to be ESG compliant in terms of carbon emission. Our company, for example, we are committed to be carbon neutral by 2040, and with a year-on-year reduction plan from today. And so you have to have the material used, the designs, everything has to be compatible to environmental protection and services. With that, so what will drive the future innovation? Basically, one is the faster internet. The internets will go from megabits range to terabits. So those kind of speed when it comes, you need to have some of the challenges which will come. Existing electronics design circuits cannot handle that kind of bandwidth. So you will have the last minute or the last mile restrictions when it comes to the equipment level. So that's where the co-packaged optics, the fiber optics communication which comes to the equipment, which also need to have optics inside the circuit. So you have semiconductor chips coming up with electronics and fiber optics combined kind of packaging. That's another thing which will drive the future of the technology. Materials, the existing silicon material used for semiconductor can have a limiting factor after some time when it comes to efficiency as well as the speed of communication. So future designs will look for new material, which is gallium nitride, graphite. That kind of materials will come. Then, as I mentioned, artificial intelligence, robotics, 3D, 5D imaging, these are some of the things which will drive the future of manufacturing. Energy storage, the large size storage by the utilities and others will drive the power electronics designs and manufacturing more challenging in future. Flexible and printed electronics, that's another thing which is going to change the electronics manufacturing field. You will have bendable displays, wearable devices, all of them will require very flexible electronics. Additive manufacturing for a quick prototype, and this one 3D printing and additive manufacturing is going to be another field, and our company is going to get into this field shortly. I mentioned about ESG focus, IoT, Industry and 4.0, and smart logistics is another thing you have to plan and think for reduction of carbon emission in your logistic area of your manufacturing. So that's another challenge to look for different way of packaging, different way of transporting, different way of reducing the transportation speed and time required. All that is which is contributing to carbon will cause a challenge. So as far as the innovation is concerned, Kerala has always been in the forefront. As you know, 1973, I think it's 1973 if I believe, it was the time when the Kerala government first announced an electronics commission and started Keltron. So that was a revolutionary change in any state. That was further copied as a model by many other states, but only I think Kerala could bring that up as a large industry. That was immediately at that time followed with other companies like OEN and others were making into other field. So it's 73 onwards, this state is already in a very advanced technology manufacturing field. Then we started in 1973. When we started 35 years ago, we had an option to go either conventional electronics like consumer electronics, TVs, and those are the only things which were being built at that time, or go for disruptive technology or very advanced technology. So we opted fiber optics as the basic technology manufacturing, networking products as the second manufacturing. That's how we brought innovation into this state. So after that, there was a number of other companies came, a lot of other technologies have come in, so we kept on adding new and new machines. So the technological advancement, as I mentioned, always Kerala is in the front. Kerala also has the first semiconductor packaging facility was started in 1980, where starting from wafer dicing, the COC, die bonding, wire bonding, all that was done in 1980 onwards. Makers Village is another initiative by Kerala, very innovative initiative, which is now being copied or followed by other states as well. So it's always been in the forefront when it comes to innovation. As far as the high-tech manufacturing, also when you talk about it, they see that Kerala is leading in terms of most of the advanced electronic manufacturing. We have fiber optic and communication system starting from a wafer to system level. We manufacture laser diodes, laser transmitters, starting from a gallium arsenide wafer. And medical electronics, all kind of diagnostic equipment, radiation therapy equipments, they're all built in Kochi for global manufacturing companies, medical companies. Aerospace, critical electronic subsystems for military as well as civil airlines, are all built in Kerala, in Trivandrum, Kochi, and other places. Defense electronics, same thing, sonar, torpedo, radar, fiber, laser weapons. These are made in Kerala for the last 20 years. So you take any of this, the space electronics packaging for launch vehicle as well as for the satellite, semiconductor packaging, as well as robotics and automation. So all these fields, you will see that Kerala has always taken the lead and has been in this field for a long time. You have experienced engineers, technicians, and available in the state. This is one of the, our factory which has the Industry 4.0 adaptation has been completed. It's completely, so Industry 4.0, it involves the, basically machine-to-machine communication, smart sensors, connectivity, as well as the, what you call, which increase the optimization of your assets, improving productivity, as well as the quality. So this has been one of the model for the state. So skilled workforce, you don't need any explanation. We have enough skilled workforce here. It's not only supporting manufacturing companies, but also the design houses in state is all manned by people from this, bright engineers from this state. For example, ISRO, NPOL, they are all, you'll find that Kerala engineers are contributing to very innovative technologies. Similarly, we have a supply chain point of view for anybody who wants to invest in Kerala or start a manufacturing operation. The raw material arrival as well as the finished goods shipments is one of the Kochi can be one of the connecting point between the east and west. We have 2 container transshipment port. We have 4 international airport in this state. No other state has got that kind of luxury. So that way also in terms of logistics, we are ideally positioned for that. So looking ahead, so sustainability point of view, Kerala also is very advanced to come up with a ESG policy by the state. So we are, the concern for this is there in every aspect. And companies like our group is already taking the lead in making sure that we are ESG compliant in every way. So Kerala is inviting is the theme of this seminar, and it's basically because 50 years of experience in electronics manufacturing, that's also advanced manufacturing. First state to establish the EMS industry culture was started in this state. Pioneer in sustainable practices with government support, that's another point of products life cycle point of view. Powerhouse of manufacturing manpower, simplified strategic supply chain. These things makes Kerala the most advantage place for you. Thank you.
Thank you so much, sir. Next, we would like to invite Mr. Ramesh Kannan, sir, to facilitate the keynote address.
Good morning, ladies and gentlemen. I would like to thank the distinguished panelists and participants for attending the important session on innovating the future, transforming electronic system and engineering. We in India are in a very advantageous position due to expected electronic growth and requirements domestically and because of the demographics. It is not an exaggeration to say the next 2 decades would see India becoming leader in technology, innovation, governance, and societal upliftment. Especially prominent would be our journey in the area of technological improvements that eventually express themselves as an electronic hardware with firmware and software associated with them. As the economic prosperity increases in total as well as per capita basis, it is my assessment that India's position will be unassailable. There are, however, many challenges that need to overcome through focused, intelligent, and concerted action. These are at the policy level, industry level, academia level, as well as individual company level. We are all aware of what they are, and we just need to list them out, actively update the changes, and take actions. Of course, there are several risk factors, but then no real development is possible without facing risk consciously. The industry experts, they expect industry-wide shifts as a result of increased competition. Most of it brought on by globalization and technology trends, where newer peers will emerge as a technological shift. Would after come one by one and will alter the playing arena. More active customers, emerging technologies, disruption, regulatory instability, and an increasing focus on creativity are all factors to consider. I would like to discuss some of the trends in products, application, technology, and manufacturing in electronic area. My friend Shafi sir has already explained most of these points. However, I would like to dwell once again on what points we thought about. Smart grid and micro grid solutions. These will add efficiency to consumers and provide a large opportunity for redesigning and manufacturing for the industry. Innovation of electrical vehicles and hybrids. The need for breathing better air and having more efficient transformations is driving this trend. Along with this are many improvements in power electronics, reimagination of vehicular functions, battery technology, public infrastructure, extra comes in. Autonomous vehicle, these are still in the offing, but futuristic, though due to regulatory challenges. But we can see a lot of work in this area too. Wearables technology trend. This is an area which is rapidly evolving with lot of new material development, nano, miniaturization, consumer preferences, etc. Then comes augmented reality, virtual reality, and extended reality, XR. These areas have far-reaching impact in the area of defense system, consumer electronics, computing, training, and other such areas. There is likely to be a lot of design, solutioning, manufacturing opportunities in these areas. Space exploration technologies. This represents the next frontier. Satellites, space vehicles have now become accessible to private sector, and one can see a lot of activity in this area too. prefabricated products or modules, IoT technologies, robotics, automation, drones, and automation. I have combined these interlinked technologies. A substantial portion of electronics manufacturing of the future would be in this area. This is a high growth area, and India can take a great lead and leap forward. Biotechnology in agriculture. This is another area which will become important for India as India becomes the most populous country in the next several decades. Food sufficiency and efficiency of agriculture will drive many improvements in design and manufacturing areas too. Nanotechnology, additive manufacturing, 3D printing, advanced material. These are again interlinked technologies. This will, after the basics of electronic manufacturing, and all organizations in this area should be aware and tracking these changes. Miniaturization and power efficiencies. This will have profound impact on new products development and manufacturing. Some of the areas are, for example, silicon photonics, wireless power transfer. This also represents an area of huge opportunity in semiconductor design, fab assembly, and manufacturing of products. Artificial intelligence, AI, and machine learning ML integration. This would represent a balance between cloud computing and edge computing. Needless to say, products would give reimagined, redesigned, and will provide great opportunity for manufacturing technology too. Last but the least, sustainability and green electronics. As we deal with the aftermath of the consuming huge amount of electronics and creating almost a crisis of e-waste, slowly but surely, this area of green electronics is becoming very important, starting with using biodegradable material like coir for PCB board fabrication, combined with other innovative methods of recycling materials, would give us possible solution in future. Now I will dwell briefly on what industry can do in Kerala state, given its positioning and advantages. My friends in SFO has already explained how good Kerala is for setting up this type of industry and their journey. We at Keynes Technology are integrated electronics system, design and manufacturing company. We have presence in India and 3 other countries. In India, we are present in 8 states of India through existing and new projects. This year, we would be crossing US dollar 360 million in revenue. We employ closely 5,000 plus globally and in India. Our plan is to grow the revenues to US dollar 1 billion by this financial year. With the renewed interest in India manufacturing by global OEMs, we are strong demand coming in. The following are the verticals of particular interest to Indian players like us for electronic manufacturing perspectives. Added to this, I feel another 10 more new companies come to India also. We have enough opportunity and enough markets available for servicing in this business arena. Aerospace, outer space and defense, robotics and artificial intelligence, medical electronics, telecom electronics. Of course, there are collaborations possible in the following areas: setting up training centers for EMS, semicon, and PCB fabrication, EMS factory in a vertical focused, starting with medical electronics, engineering research and development centers for electronic devices, engineering research and development center for semicon. The industrial players can work with specific state entities and develop respective business plans. We in the industry would require commitments from the state governments on possible incentives and subsidies to start of the activities and overcome initial commercial burdens and disadvantages. Then the industry will endeavor to bring high value added work in the state. Once again, my thanks to Invest Kerala team and KSIDC for giving me an opportunity to speak, and I am confident that these interactions are the beginning points or seeds that would grow into larger and vibrant industry development. Thank you once again.
So it's a time to begin the much awaited panel discussion. For that, I would like to request our session moderator, Dr. R. Muralidharan sir, to proceed with the moderation of the panel discussion. Thank you.
Distinguished dignitaries on the dais, off the dais, friends and colleagues. First of all, let me thank KSIDC for giving me an opportunity to be present and share my thoughts and also moderate the session. And many of the points I want to share has already been shared by both Mr. Shafi and Mr. Ramesh Kannan. So my task is going to be a little less. Thank you. And let's start with the beginning. I mean, I'm also a professor at IIT Tirupati, so like to share things the right way, as if I'm teaching a set of students. So pardon me for that. If you look at the first semiconductor patent in the world, it was by an Indian. Many of us may not know that. I also came to know only some time back. It was J.C. Bose who did the first patent of a semiconductor. It was a diode for receiving microwaves. And it was in the year 1901 he filed it, and 1904 the patent was granted. The US patent 755840A. Okay? So India has a big history of starting the semiconductor business, okay, long, long ago, 121 years ago, right? The patent was granted to us. And it was made of galena, lead sulfide, a semiconductor diode. That was the patent that he got very early. And he was also the pioneer of wireless communication, okay, which IEEE recognized, and now Dr. J.C. Bose is considered as the pioneer in wireless communication too. Okay. So today, in 2025, we are at the 77 years of inventing the transistor. Okay. And the transistor is considered to be the most significant invention from 1900 to 2000. An IEEE survey has shown this. So only 77 years back, we had a transistor. When it was invented, not much was thought about it. But today, we have billions of transistors in a chip. Right? Look at the growth of 77 years. Okay? Coming back to the India's import, the last financial year, 23-24, we imported $34.4 billion worth electronic components. $34.4 billion worth electronic components we have imported. And it is expected to reach 100 billion by 2030. In another 5 years, we'll be importing close to 100 billion $1 billion worth electronic components. Okay? And remember, India, if you look at India, at the Global Innovation Index, we are 39. We were 48. The last few years, we have been able to reach 39. So we are 39th innovative country in the world. Okay? So we need to move up this chain heavily to be really self-reliant. That's the point I was trying to make. Okay? I don't know how many of you know a Keralite, Raja Ravivarma. He started the first lithographic, fine arts lithographic press in Mumbai, again in 1894, right? And this is how he could democratize fine arts. His own great paintings were made available to the common man at a very cheap rate through this lithographic printing press. Why did I mention this? It's lithography that is creating all the chips that we need. Okay? So today's VLSI chips, the very large scale integration. So today we are able to commercially achieve 2 nanometer process nodes, the famous N2 process at TSMC Taiwan. Okay? And its yield is only 60% is what the gray point says. And China is able to make up to 5 nanometers. And there's only one company in the world, ASML, in Netherlands, which can make the extreme UV lithography machines, okay, which is of 13.5 nanometer wavelength UVs using lithography. So we had a lithography press in 1894 to democratize paintings, and today we are looking forward to getting lithography machines that can make semiconductor chips in India. My earlier speakers did talk about the newer technologies that will going to come to the electronics field. They are fast evolving hybrid chips, nanotechnologies, optical computing. There's one big question going around: will photonics kill electronics, or will they be complementary? We are yet to understand what will really happen in the future. We should be prepared for both. Maybe it's only photonics happening. The photonics dissipates less heat and is much faster. The electronics is dissipating more heat and it's less faster than the light speed. Or will emerging quantum technologies and neural processing units, what will they do with photonics and electronics? Okay. The future is very unpredictable. What does that mean to us? We need to do more of R&D, more of agile nature to change as we go ahead. The latest announcement from Microsoft, a predominantly software company, is they came up with the first quantum processing unit powered by so-called a topological core. A topological core is something which is neither solid, gas, or liquid. It's a 4th or 5th state of matter. So using that, they could make a chip for quantum computing, which they claim can scale to 1 million qubits. Okay? The biggest invention before that was the Google's Willow chip, which had 105 qubits. It was only announced in December 2024. Within a month and a half, Microsoft could announce the famous chip Majorana 1. Okay? So look at this pace of change happening in electronics. Okay? So what is, it's a busy slide, so I will not go into the details because lack of time. But one thing I want to share with you all is the electronics field is changing very fast. It may not be any more electronics. It may be photonics, or maybe quantum systems, or something new. So what does this mean to us? if we have to innovate the future, we should be open to adapt. As Mr. Shafi said, Industry 4.0 or Industry 5.0 may come up, where our existing plants may change day by day, right? We should be ready for that. So there is a lot of R&D required in the electronics industry. Okay? So if anybody is wanting to set up a company, like if you look at SF, I have been studying a big fan of SFO technologies, because his founder, Mr. J. Hassan, was I'm his fan. I met him in the US, and he was a mechanical engineer who did a lot of work in semiconductor manufacturing, and he's a fellow of the IEEE. He got a fellowship from the IEEE, nothing to do with mechanical engineering, right? Which was a very great honor, even today, the world over, right? And he started innovating things here, seeing the future. So I was very happy to hear both Shafi and Mr. Jahangir talk about their path. And if you look at in detail, what did they do? They just not did only manufacturing, they did combined R&D with manufacturing. So this is the future. So if you invest in Kerala, you have 195 engineering colleges. When I was a student here, there were only 5 of them. Today there are 195, and we have a young population. So this can bring in a lot of R&D team, really experienced thinkers, innovators, right? We may not be hardworking in Kerala. We always worry about number of hours of work, etc. This is what I was told. But we are innovative. The short time we work, we are able to come up with newer things, different ideas, disruptive thoughts. So the world over, if you look at the systems, they are becoming software defined. So this is a typical example I show everybody. You can see a Premier Padmini Fiat car, okay, which was one of the most popular cars for 40 years, right, in India. It had no piece of electronics in it, not even a single piece of electronics was there in that car, right? And today you look at Tata's Nexon. Sorry for talking about only Tata Nexon, because that's the company which paid my airfare to come here, right? So the Tata Nexon is a fully electric car with huge amount of electronics in it and huge amount of software. It has got 20 million lines of software code in it, right? So what is saying is, the future is not only hardware or software, it's the right combination of the two, okay? The software needs something to run on, so it needs the right hardware, but programmable hardware. So the future will be bespoke solutions. It will be no more, everything will be same. If I order a watch, it will be meant for me, the size, what it features, etc. Industry 5.0 can do that. Order a watch for you. See, today we go to buy a pair of shoes or a shirt, we say M, L, and shoe size is 9, 9.5. If you remember, your left leg is different from your right leg, but you still wear the same size shoes on both the legs. Why should we do that? The same thing is going to happen in electronics. If I order something online, it knows my characteristics or profile, it will bespoke a solution for me. A television will be made for me and you, right? So this is going to be the new trend, which means a right combination of hardware, software, all of that will be required, okay? And the major challenge is the digital autonomy. Do we have our own chips? Can somebody deny us? We're talking big. Somebody doesn't give us the sensors and the processor chips, we can't do anything. Because everything is today software driven or software defined systems. We may have the best of embedded software, but if you don't have the right processors or hardware to run them on, it won't be a good product. We will not be able to make even a product. With this, I thank you all for your kind attention. So we'll go with the panel discussion. So may I request, yeah, okay. So she wants to interfere.
Thank you, sir. And we do have another renowned dignitary also to be a part of the panel discussion. So that we would like to invite Mr. Radha Kishore, sir, to the stage. He's a director of HC Robotics. So please do come to the stage. Welcome, Sri Kumar Nair, sir. Okay, so we would like to invite Commodore Matthew Letra, sir, to have a presentation. So please do.
Good afternoon, all of you, distinguished and eminent personalities on stage, off stage, and all the friends. So I just put, I was asked if there is any slides. So I said that, no, my, whatever I wanted to kind of just give one bit in a single slide, because when you have a short time and a very busy audience, it is better to kind of compress everything into one slide. So it is just our company slide. I represent Krasny Defense Technologies. We are a small company, but exclusively in the defense area, a company which is promoted by a veteran and propelled by veterans. And incidentally, most of us are Keralites, but we didn't have any presence in Kerala. And last year we came to Kerala in collaborating with Keltron. We have established a joint venture, and I will cover in a little while. Our aim is to kind of come to a system level of manufacturing rather than living or staying at the tier 3, tier 2 level, come to a system level. Because when he started, Jahangir sir has just said that Vasco da Gama came, he took spices from here. Similarly, a lot of electronic manufacture happens here for Thalis and a lot of companies, and they take all the things away and they put it into a system and sell it to us at 100 at times the price. So unless we grow to that level and start coming to a system level and deliver, we will never be able to really leverage on the value of our efforts and the resources we have here. So quickly, I myself being a veteran with more than 3.5 decades of service and handled most of the complex electronics and systems. So I just wanted to focus my 2 minutes into the challenges of defense electronics, as electronics has got a wide spectrum of utilization and applications, but you know, defense, space and medical, they are the most complex of the electronics. And while not taking away, the defense electronics is complex and advanced technology. It's a long road from the drawing board to the battlefield. And we are kind of driving indigenization, but still I think we are quite far from getting a 100% indigenous solution. So there is a critical requirement to acquire technologies, collaborate technologies, and we should be first looking at getting core technology and make peripheral systems, learn more about the core technology and kind of enhance our capability and move on to getting the full systems. And another thing is that I see a lot of companies jumping into startup ecosystem. There is a lot of statistics which is flowing around last 4-5 years. And definitely the people who have jumped into the startup ecosystem, you have to realize one thing. Defense electronics, defense industry is a very, very costly proposition. First of all, it is long cycle times. You can make one, and it is not a lab model or a lab technology. We need to have a lot of validation, testing and ruggedness of the system. So Many of the startups, we find that kind of suffering because they don't have the stomach to absorb the depth which is required. That next is for defense electronics, what is required in the ecosystem, since we have industry, major giants here, government officials here. We have to have a testing and validation kind of an ecosystem, which is actually lacking. This year, about few months ago, like I should say it's 24, we developed an electronic system. I wanted to carry out the testing. I had to run around at many places, and my testing has costed me double the cost of my development. So first and foremost, we still don't know, like in the international standards, whether it is JSS standards or GO standards, what all the testing has done, required to be done. There is no place where you can get everything done. We have to kind of shift from one Chennai to Hyderabad to some other place like that. So that is an area, if you have to really succeed in defense electronics, that is required. Defense, why it is testing is required? Because there is no second chance, neither for the guy who is using the equipment, nor for the other side, because only one chance. You can have collateral damages if the accuracy is not there, and the infrastructure and cost is quite high. Now, the last but not the least is the business volumes. Requirements are less. If you buy a quality system, the replacement will come far later. And global market, we are still a long way off finding a market for a key defense system, because you have NATO-driven markets or Russian-driven markets. So these are the main things. And the last point I wanted to say is what I said. As Krasny model, we wanted to get core technology from abroad, utilize or leverage on the infrastructure and capabilities of local industry, bring it to a system level. So we are setting up an electronic integration facility in Kochi, where we plan to integrate and go forward with complex defense systems like radars, sonars, and other underwater systems. That's all what I wanted to say. Thank you for the opportunity, and thank you for a patient hearing.
Hello? Yeah, good afternoon. Now we'll start the panel discussion. This is on innovating the future, transforming electronic systems and engineering. We all heard the experts talk about in electronics, every day newer disruptive technologies are coming up, and how Kerala can be a facilitator for those kind of industries, okay, which are changing very drastically, which has to combine R&D as well as the manufacturing, and keep changing them from time to time. The right mix of hardware and software, the right mix of newer technologies, what to put in, what not to put in. And India is very famous for detailed engineering, but not for systems engineering. So I'd like the panelists to also reflect on how we can solve this problem of creating a system, right? We have yet to create a large system in India, our own, from scratch. We are good at assembling things and manufacturing them and giving them some value, but not at a large system. So that's one gap that is there. So let's see how the panelists will help us understand this, and how and why Kerala is the right place to do these things. So first I request Admiral Sri Kumar Nair to share his views.
First of all, good afternoon to all the distinguished dignitaries on the dais, and my apologies for having joined late. I had to go for some other meeting. But I'm told that a lot of things about electronics, its manufacturing and component manufacturing to certain system level has been covered in the various keynote addresses that's been done today. Now, Murli sir brought out a very valid point, how to make a large system. See, there are two parts. One is you need skill. Skill set is required when you want to make a component, make certain items, say even a fiber optic cable to make, or even to connectorize it, you need a skill set. That's an important aspect. But when you want to make a system, you got to have large domain knowledge. For example, you want to even make, say, a mobile like this. It integrates an antenna which is so small to so much of signal processing embedded in an electronics to a display, an HMI, and what have you. And then you have added a mic so that, you know, it's a huge. So you need a large domain knowledge if you want to develop a system. So two types of sets are required. One is the skill set to work hands-on on certain things. Second is the domain knowledge to put a system into place. My experience has been 37 years in the Indian Navy. I've worked with most of the DRDO labs, the defense PSUs, the private industry, etc. We have had a fair struggle, but it's not that we are very far off. We have achieved major successes in various fields, be it radars to sonars to torpedoes, etc. And in the commercial segment too. So it's just that we need to jointly apply ourselves to go to that next level where we independently make our own large systems. But having touched upon that, what's the trend that I want to say is most of the things are going autonomous now. Gone are the days when, when you will have independent systems. Systems will have to operate with each other. You see the warfares that are happening. It's a swarm of drones, swarm of underwater boats, swarm of automated, boats or underwater boats that's functioning. In that scenario, the system becomes more complex. You need very, very high-end sensors. Sensors become an integral part of your electronics. In fact, electronics get integrated into sensors. The signal processing has to be very high. Communication has to be enabled. That's only when autonomous systems can work in a swarm environment. So that's one area I think we need to leapfrog into in the fastest possible way, so as to have that cutting edge and to be able not only to develop for the Indian market, but to be competitive in the export world. Thank you so much.
Thank you, Admiral Nair. That's a good suggestion he gave us. Sensors is very important. We need to develop them and integrate them. And other thing is, the major thing is the communication modems. Okay? Only 3-4 companies make communication modems in the world. Qualcomm, MediaTek, Huawei. We cannot find any more guys who make these communication modems. And you saw recently what happened in the Israeli warfare, right? So communication is very important. Those chips are very important. So we need to design them ourselves. Sensors, we need to design them. Otherwise, we will not be able to make a large system of our own, an autonomous system without any dependence on others. Now, may I request Mr. Raja Manikam to share his views, please?
I have a totally different view of, I'll speak about semiconductor because that's the only thing I know. See, fundamentally, right, the semiconductor is all defined by Western countries, right? We had very good examples of, the lithography being democratized. We talked about the, transistors and so on, right? Now, I think, when you talk about all these systems and all that we do, we seem to define ourselves with what the Western countries have put in front of us. And we try to either, copy that or build on top of it. I think we need to have our own indigenous way of solving problems, right? I'll give you an example. If you throw a problem to NVIDIA, right? You all heard about NVIDIA with the AI and all that, right? You will have a very expensive solution because NVIDIA will only sell expensive things because they want to make those kind of margins. If you throw that to a company that is struggling, that has to make ends meet, their solutions will be completely different. Will it be as good as NVIDIA? May or may not be, but it will be a frugal solution that will address the real problem for the masses. My view is this, that we are just embarking on the semiconductor, just like what happened in 1901 when J.C. Bose came up with the patent, 1904. I think we are at a cusp of, getting our seat at the table in semiconductor, and we don't need to do the ways that has been done from the wealthy countries. And I think we have to define ourselves, right, how we want to solve a problem. And semiconductor is not just about transistors and so on, right? Yes, it was transistors, and we have learned how to pack more and more and more and more of transistors, and that is why we have this, billions and billions of dollars of worth of the fabs that are coming up and so on. I'm of the opinion that we can chart a totally different path, because this is not, we are in 2025. We don't have to do what people started doing 1950s and 60s. I'm from TI, and the Texas Instruments, right, was one of the pioneers in, developing microprocessors and so on. But now we are talking about totally different way of computing as well. So my suggestion is this, right? One is our workforce, instead of just learning, how to become a service provider to somebody else, to create more innovation, hands-on training, hands-on activity is I think missing in if you look at it from a skill standpoint, from schools and so forth. The second thing is use what we have and develop them completely, ourselves, right? Which I think will be a lot more frugal, which will actually solve the problems. So my view is, when you're creating these large systems and so forth, we will create our own large systems which will look completely different from the other guys, which is okay, right? Which may solve 94 or 95% of the problem.
Yeah. So thank you, Mr. Rajamanikam. This is a very Mangalyaan and Chandrayaan and the recent DeepSeek. Okay. They were all frugally engineered solutions. So frugal engineering is one topic I also teach. I forgot to mention that. Okay. So we need to solve problems in a different way, not the way ChatGPT does. And this is what DeepSeek did it. And in India, we sent Mangalyaan lower than the cost of the movie Gravity, right? Frugal engineering, thinking differently, achieving the same objective. Yeah, that's something that we can all imbibe on. Thank you. That's a very good suggestion. Now, may I request Mr. Radha Kishore to give his views, please?
Thank you, sir. On the one hand, we have all these big companies, and I am a small company, MSME, supporting or contributing to the success of these big industries, whether Tata's or semiconductor companies, or for that matter, Mr. Jahangir's company. Ours is HC Robotics, which is into drones and UAR camera company, manufacturing company. We have 60 people, very strong engineering support team. We actually do a lot of cutting edge research at this moment. And on one side we are talking about large systems, and on the other side we actually talk about AI for the AI based FODs for the Air Force, or flight tracking, or wildlife detection and that type of things on the one side. And the other side, we also IDEX Challenge winners for one of the naval Indian Navy that is developing a pod for the naval aircrafts and things like that. So here, the opportunity in Kerala, what we see is, as a small MSME from Hyderabad, we can actually contribute lot to the companies that are sitting on this side. We are also working with Caltron very closely on on a overseas project at this moment. Maybe probably next 15-20 days we will be able to announce that project. And on the other side with NHA and ATMS and things like that. So, so some of the niche technologies that we are into, and we are focusing on those things. And of course, we can discuss further at some point of time. Thank you.
See, nothing is small. It's the small that makes the big. Okay? So one thing that we need to worry about the future is the startups that's going to change the way we work tomorrow. They will be more agile, more hungry. So many big companies today are collaborating with startups. Right? In our own company, we said that, look, if I internally want to get something innovated, too costly, too bureaucratic, too many proposal writings, and I have to prove that can be done, that can be done. If I connect with a startup company, they are easy to help us. They are very agile, very, very hungry, and they can come with the right solution before time. So if we look at the large companies in the US, they all innovated not in-house. They connected with startup companies. The whole of Israel is a startup nation, full of startup companies. So collaborating with startups is the next big future for electronic systems engineering. Okay? The overall system engineering you may do, but each component you can specify and get it innovated by a startup company. So the collaboration between startups, academia, and industry is going to work. And I'm sure Kerala has that ecosystem, and hence again repeating that the right place to start a industry which will be looking forward and changing the way that technology changes. So with this, I'm now requesting Commodore Matthew to share his views, please.
Already gave a brief overview of whatever kind of related to this, but in the light of whatever discussions we had, as again sir has mentioned that what is important is the whole ecosystem. The startups are to be kind of encouraged to contribute, and the bigger companies have to do the handholding. I think the IDEX which has come about is one kind of initiative in that direction. Fortunately, we are also lucky to have one IDEX joined with Caltron. We are developing that IDEX project. So that is a very, very kind of encouraging way forward, as it was discussed in the first hall in the morning when we spoke about defense and aerospace. So the creating the ecosystem and nurturing the startups to contribute to the larger pool and getting the larger systems is the way forward.
Yeah.
Right. I see the difference in startups in the US and Europe and versus what happens in India. Most of the startups are starving. Right? They hardly get funding, and then a lot of them end up ultimately doing some IPs and stuff like that, and then they never become product companies. Whereas when you see in US or Europe and in Japan and so on, there is a lot more support, especially from the private sector. Okay. So one of the requests that I have is the Tatas of the world and the bigger companies to actually support them. Not the the first question the big companies ask is, what is the ROI? What is IRR? And all these kind of financial metrics that kills them. You need to have a separate ecosystem, financially different ecosystem for startups. Let them thrive, because they are going to be the future. We all say they are the future, they are the future. But how many of these large companies are supporting them? Right? I think it's so far, government is actually doing a good job, both state governments and the central governments. most of that are all government initiatives. I think it's about time that the private sector, owns up to some of this so that, they will become feeders for you, for the next ESDMs of the world, right? Who is going to feed them? If we are thinking that we're always going to get foreign companies to come and they give us some work and then we do the work, we export it, right? This has been our mantra for so many years, right? We're always service providers. How do we become our own, right? Create our own, control our own destiny. And these are the startups that these large companies need to feed to create the funnel so that eventually, right, 5-10 years from now, we will be, sending out products to the world. So please take that as a, a suggestion.
Yeah, yeah. Thank you. Yeah. So if you look at our key takeaways, one is strong collaboration between academia, startups, and industries required. And industries, the larger ones, need to nurture the startups to really innovate the future. Okay, they themselves may not be too agile to do that. And second is the policies. Okay, we should have encouraging policies that will help industries set up here. And third, big takeaway I want to share with all of you is systems are going to change. We need to look at large systems, how to frugally design them, especially larger systems which are a combination of hardware and software. And semiconductors is a big thing because that's the basic component that we need to build a system. And yes, India is slowly starting to make them. And like China did long ago, we should have done long ago, but anyway, it's always a good to start even if it's late. And the last but not the least is I would like to let the young colleagues know that you are the future and you should do the right learning and be a lifelong learner. Industry is changing, technologies are changing. What I learned in CET in 1977 is not what I'm practicing today. But that gave me the base to learn more, right? So be part of professional bodies, keep learning. And recently I was in a Department of Technical Education meeting in Trivandrum, where they said they will revamp the education, the syllabus and education system, technical education in Kerala, which is what I wanted to see, that if industries have to come here, you should have the right engineers. We had good earlier, but how to continue the good for a long time, change the syllabus. The technical education cannot be same all over, right? So good things are happening, and I again wish Kerala all the best to be the pioneer in electronics industry. As we started with ISRO, Keltron. I forgot to mention Keltron's R&D is today one of the best R&Ds in the country, CDAC, right? And Tata Group uses them heavily to develop basic subsystems, right? And so we have a long history. SFO is another one, right? So all of them invested in developing R&D. And remember, two words, know how and know why. I know how it works, but I don't know why it works. If I don't know why it works, I cannot change it. I cannot do a frugal engineering. I cannot modify tomorrow. So remember, when you go for a manufacturing technology transfer, they'll tell you this is the know-how. Don't be happy with it. Learn the know why. With this, thank you all and wish you all the best. Yeah. Last is any questions from the audience which the panelists or anybody would like to ask, please. I think there's a hand there. Can you?
Thanks. I'm Pradeep Kumar, a proud Keltronian, ex-Keltron man, management systems, technical auditor, consultant and trainer. I was fortunate to audit companies such as Nest Group, SFO Technologies, and some Tata establishments, BEL, etc. Now coming to my question, we all know that there are product standards, fundamental quality benchmarks. We have the management system standards. Of course, all of you know ISO 9001, which is the basic benchmark standard. But there are advanced standards, especially for telecom, called TL 9000, for information security, for medical electronics, etc., etc. So my question is to all of you, but beginning with Shafi, my former colleague, how do you look at the future of compliance to various management system standards for electronic industries? We know that not all companies go along with the standards. So I would like Shafi to answer first, followed by others. I hope my question is clear. Thank you.
Yeah. Nice to get connected to you after a long time. Yeah. You have seen our company, I think you have already audited, and we are one of the, I think in Kerala, you will see that we are one of the company who have the maximum number of compliances in terms of standards, right? That includes some of the industry compliance standards like automotive, medical, aerospace, and things like that. There are security-related things like 27001 and so and so. And there are certain business excellence point of view. That's the point which you are touching upon. Now, one of the important aspect of compliance required is the, as part of ESG, the governance with the ethical business practices. All of them are auditable now, and it is. And so we are a member of a responsible business alliance community, and we are compliant to their standards of operation with reference to governance and ethics and things like that. So we always, or any company that matter, need to be very aware of this aspect that they have to have a management, compliances with reference to industry standards. And people who are involved in exports should specifically be careful about this, because some of the companies can take you away from their vendor list if you don't comply to certain basic management practices and standards. So that's a very important point which you have said. I think companies are, of course, in our company is aware of it and try to get as compliant as possible. And I think every industry should have that awareness and compliances.
Adding to what Mr. Shafi has told, I think we have to push the government to take up this in the schools, college, and this has to be driven as a practice and culture. Today, industry is putting lot of effort after bringing students from the college to make them understand how important it is. I can see a lot of student volunteers here. So you all have to take effort to bring in compliance, because we are in a culture where for everything we are questioning why we should do. Is it worth? So taking that point, we have to drive it in schools, colleges. When it is engineering college, there should be subject on these matters so that people take interest, and then when it is taught to them, they understand it fully. Otherwise, it will go on like this. Because of pressure, people will be doing it. Thank you.
Thank you.
Hi, my name is Mithun. I am a startup founder in the semiconductor space. So our company is called Nanomatter. The company is on developing semiconductor deposition equipment. So our aim is to reduce the capex and opex of semiconductor deposition. So as a part of that, we make deposition equipments, and we got the first order from Tata Institute of Fundamental Research, and we are delivering by the end of March. My question is to Shafi. So you told about the advantages of electronics manufacturing in Kerala, but what are the challenges for a manufacturing sector in Kerala, considering Kerala don't have a manufacturing in history?
I think there is no specific disadvantage to Kerala as particular, because whatever disadvantage is available is the country's overall disadvantage. Basically, you know, in any electronic equipment, if you take about 60 to 70% of the parts have to come from abroad, because there is no domestic supply chain built up so far. And some of them are getting, coming up in the country, including the semiconductor fab, OSAT, memories and things like that is coming up. Passive components are also more and more are coming. But component availability is one of the limiting factor for manufacturing in the country, electronic manufacturing. And we are competing with countries like China and those where these components are available plenty at near shore next to their place. So the logistic cost of transporting it and the preferential price which they can enjoy and being non-competitive, all that kind of related issues comes out of that. So component availability and increasing the indigenous content of that electronic products what we build is the biggest challenge as far as we are concerned. Other things are all challenges, if at all, if it is there in terms of logistics, in terms of people say that we have about 10 to 15% handicap compared to China with reference to manufacturing. Okay, because of multiple factors. There are factors considered the cost of power, cost of finance, cost of logistics, all that like that, and certain duty structures, inverted duty structures. All that put together, we have about 15% disadvantage with reference to government. To offset that is what the government comes up with multiple schemes like PLI schemes and so many things like that, which supports, which will take part of that handicap away and make you a level playing field in this industry. So that's the scenario, right? Thank you.
I think actually Kerala is, you have an advantage, especially for equipment like yours, right? See, you don't build thousands of them, right? You may build 10, 20, 30 in a year, right? So for those small scale type of equipment where you need the very customized parts, I think probably Kerala will be a better place, because if you go to Bangalore or some of the big cities, right, they want volume. So Kerala could be an advantage, and plus especially when you have people like CDAC and ISRO and Keltron and all that. So a lot of these little things, right, you want to get done that Tata was also using as projects. You could use them to develop some of those fundamental stuff.
One of the side comment is there's an Indian Rare Earths Limited near in the district of Quailon. So I never knew this, though I was born nearby that. And sometime back there was a big issue that rare earths are the ones which are required for electronics, a key component in electronics, right? So they are on board Indian Rare Earths Limited, and then I found out that they only export the basic raw material. They don't add any value. Okay? So if we start adding value to the titanium and the rare earths and everything else that we have in Kerala, it can be a good resource, because the advanced materials is a very big challenge for the whole world. Okay? So apart from, for feeding into electronics industry, this also should be thought about, and there should be a plan with the government to how to add value and really give the right things out of the rare earths and titanium and other things, and not only spices. Okay? With this, I thank all the panelists for their right views, and I hope the government is hearing, Kerala government is hearing us, and urge each one of you to come to Kerala, invest, and urge each of the youngsters here to be a lifelong learner and be the right partner for the industry in Kerala. Thank you. All the best.
Hello. Indeed, it was a great session ever, and we would like to give a token of appreciation for our renowned dignitaries, and we do recognize the gracious presence of Sri Madhavan Nambiar IAS. So we would like to invite Madhavan sir to the stage. He is a former Civil Aviation Secretary, Government of India. So we would like to request Sir to give memento to our beloved dignitaries. So first of all, we would like to invite our Muralidharan Sir to receive the memento. And now we would like to invite Jahangir Sir to receive the memento. Now we would like to invite Ramesh Kannan Sir to receive the memento. Now we would like to invite Vice Admiral Srikumar Nair Sir to receive the memento. Now we would like to invite Rajamanikam Sir to receive the memento. Now we would like to invite Commodore Matthew Letra Sir to receive the memento. And now we would like to invite Mr. Radha Kishore Sir to receive the memento. Well, indeed, it was such a great pleasure to have such renowned dignitaries and to be a part of this amazing session. And dignitaries are requested to stay back to have a group photo.